Hello friends! In this video we will be discussing quartiles, percentiles, the 5-number summary, box and whisker plots, and outliers, all in under 8 minutes. Let's begin by discussing the idea of a percentile. The kth percentile is the value in the distribution such that k% of the data falls at or below that value, and 100 minus k% of the data falls at or above that value. For example, if we are discussing test scores in a statistics class and you were to score at the 70th percentile, this doesn't mean that you scored a 70% on the test. It means that 70% of the scores in the class were at or below your score, and 100 minus 70% or 30% of the scores were at or above your score. Here's what it might look like on a histogram. You may have scored somewhere between 80 and 90% on the test, but you might be at the 70th percentile because you scored better than 70% of the students and worse than 30% of the students. There are 3 percentiles that are so important we have given them their own names. They are the 25th percentile, which we call the first quartile or Q1, the 50th percentile, which is the median, or sometimes called Q2 or the second quartile, and we have the 75th percentile, which we call the third quartile or Q3. These values are called quartiles because they split the dataset into quarters. Think of 4 sections, each containing a quarter of the data. Q1, the median, and Q3 are the numbers that fall on the boundaries of the 4 sections. Let's talk about how to calculate percentiles. Unfortunately, there end up being several different ways to calculate percentiles. I'm not going to discuss why the methods differ, as it's a bit tedious and detailed and really not that important for our discussion. This is the process we will be using to find Q1, the median, and the third quartile, which are the 25th, 50th, and 75th percentiles. First, order the dataset. Then find the median, which is just the value in the middle of the distribution. The first quartile is the median of the bottom half of the distribution, not including the median. The third quartile is the median of the top half of the distribution, also not including the median. If you use percentile formulas for steps 3 and 4, you'll sometimes get slightly different answers. Let's take a look at an example. Here we have a data set with 8 numbers, which are already in order. The median is based on the 2 middle values, which are 15 and 21. In this case, the median is the mean of the 2 middle values, which is 15 plus 21 divided by 2, which is equal to 18. Next, we need to find the median of the bottom half of the distribution to find Q1. We don't need to worry about the restriction of not including the median, since the median of 18 isn't even part of our dataset in the first place. The median of the bottom half of our dataset is the mean of these 2 numbers, 3 and 9, which ends up being 6. This is the first quartile. The median of the top half of our dataset is the mean of these 2 numbers, 22 and 26, which is 24. This is the third quartile. In the case of an odd number of observations, the median will be part of your dataset, and then the 2 halves of the distribution for purposes of calculating the quartiles will exclude the median. Here the median is 9, making the bottom half 2, 4, and 4, and the top half 11, 12, and 15. The median of 9 is excluded from the 2 halves for the purposes of finding the quartiles. Q1 is the median of the bottom half, which is 4, and Q3 is the median of the top half, which is 12. Let's move on to the 5-number summary of a dataset, which includes the following 5 numbers: the minimum value, the first quartile, the median or second quartile, the third quartile, and the maximum value. For our dataset, the 5-number summary is 3, 6, 18, 24, and 53. I'm using the values for Q1, the median, and Q3 using the traditional method, opposed to using the percentile formula. The 5-number summary is often graphically displayed on what is called a box and whisker plot. There's only one axis, which is the horizontal axis containing the range of values from the dataset. The box starts at the first quartile and ends at the third quartile. The median is represented by a vertical line somewhere in the middle of the box. The maximum and minimum values are the whiskers of the box and whiskers plot, which are typically represented by lines stemming out from the left and right sides of the box. The 5-number summary and box and whisker plot are simple ways to easily gauge what the shape and range of the data look like. Another common number that we calculate is what is called the interquartile range, which is simply the third quartile minus the first quartile. In our case, we have 24 minus 6, which is equal to 18. The interquartile range is often used to help determine outliers, which are numbers that differ significantly from most of the other values in a distribution. There is no universally accepted approach to identifying outliers, but one approach labels an outlier as any value that's less than Q1 minus 1.5 times IQR, or any value greater than Q3 plus 1.5 times IQR. In our example, Q1 is equal to 6, Q3 is equal to 24, and the IQR is 18. Outliers would include any values smaller than 6 minus 1.5 times 18, which is negative 21, and any values larger than 24 plus 1.5 times 18, which is equal to 51. Glancing back at our dataset, we see that none of the values are smaller than negative 21, so we have no outliers on the left side of our distribution, but we do have one value larger than 51, which is 53. This tells us that 53 is an outlier, and we should look more closely into why this value is so much different from the rest of the numbers. It could be due to a mistake in data entry or in the measurement process, or there could be other reasons why this number is so big. It generally isn't a good idea to simply dismiss or exclude outliers without investigating them first, as sometimes they can tell you meaningful information about the population the values were drawn from. Alright, my friends, we have finished our discussion of percentiles, quartiles, box and whisker plots, and outliers. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.